Good morning everyone. This is Rohit Singh, Branch Metallurgical Engineering, 5th semester, BIT Sindri, and my topic is New Product Development, Characterization and its Failure Analysis. Project Summary. In this project we will study about what is the reason for new product development, its importance of characterization and how to deal with the failure analysis. Introduction. The main objective of an aerospace designing process is to produce an aircraft that is strong, lightweight, economical, and carry an adequate payload with a sufficient reliable to safety fly. 40 years ago, commercial jet consisted of 70% of the aluminium, but as the time passed on, in 1985, Airbus 310-300 was the first carbon fiber jet which consists of 20% of the aluminium. So in 2015, HRL Laboratories in a joint venture with Boeing discovered the world's lightest and the strongest material known as micro lattice, but this is only possible after the continuous characterization of material and its failure analysis. Material used for commercial jet making. The reason for using the aluminium is its low density of about 2.7 gram per centimeter cube, which is one-third of that of the steel, and it has an anti-corrosive mechanism, stronger as titanium and much cheaper. Aluminium alloys are the number. The most common number used for aircraft making is 7075. It consists of zinc, magnesium, copper, and the small traces of manganese, silicon, iron, and titanium. According to the given figure, the numbering is done on the basis. For example, 1XXX indicate the most pure aluminium alloys, whereas the 6XXX represent the significant amount of magnesium and the silicon that has been added to the aluminium. The second digit represents that has been specific modification to one of the alloying element. The third and the fourth digit are used to label the specific alloys. 7075 alloys has a greater mechanical properties such as it has a 83 kilo-pound per square inches of ultimate strength, 73 ksi of tensile strength, and has a 11% of elongation at break. And talking about its chemical properties, its melting point is around 477 degrees Celsius, its thermal conductivity is 196 degrees Watt per meter Kelvin, and density of 2.18 gram per centimeter cube. Cones of aluminium. Due to its lower melting point, it loses its half of the strength at 600 degrees Celsius, and it has a lower modulus of elasticity of 10 megapound per square inches. In 1952, de Havilland Comet was the first comet jet airline which is composed of 70% of the aluminium, but this plane crashed due to the certain reasons. One, metal fatigue, and second is the overstressing on an airframe during flight. As from the figure, we can see that the fatigue cracking was found, which is originated from the aft lower corner of the forward escape hatch and also from the right hand aft corner of the windows, which resulted the plane ripped off and crashed. Ultimately, the comet was withdrawn from the service. Carbon fiber reinforced polymer. This material has a magnificent mechanical properties such as modulus of elasticity of 33 kilo-pound per square inches, ultimate strength of 500 ksi, but has a lower elongation at a break of 1.5%. This material has a stiffness by weight ratio which is over 10 times more than that of steel or aluminium. It has more several advantages over the other metals such as it has a high chemical resistance, high anti-corrosive nature, and moisture regain of 0%, and has an extremely high melting point of around 3697 degrees Celsius, which provides an exceptionally high thermal stability. Cones of carbon fiber are such that from the figure 1 we can see that when the carbon fibers are pulled along the fiber it shows magnificent tensile strength, but from figure 2 we can see that when they are pulled along the resin matrix it will get pulled apart easily. So to combat this, engineer put two fiber layers on the top of each other, 0-degree layers on the top of 90-degree layers. But according to the figure, when it is pulled along 45 degrees, the problem still exists. So in order to improve the qualities, we will keep on adding more layer until the stiffness becomes similar in all directions. But this will eventually increase the thickness of the material. So finally, microlattice were introduced. Microlattice is a 3D open cellular polymer structure can be often compared to the human bone structure. It consists of 99.9% of air. It is 100 times lighter than a styrofoam. Due to its significant mechanical and chemical properties, it has a wide future aspects. This material coated with a nickel and can be used for aerospace making. Boeing announced that after a few years it can also be used in car making and making buildings. Characterization of carbon fiber reinforced aluminum. There are three methods of characterization, starting with the tensile test. According to the figure, different specimens of a carbon fiber are cut into the required shape and the dimension. This material is fixed in a machine using proper equipment, and then a tensile load is applied till the fracture is occurred, and then the result is recorded in the form of graph. Flexural test. It is measured by the mean to crosshead position. The displacement and the flexural stress are measured at 25 degrees Celsius with 50% humidity. The graph shows the variation of flexural stress. Impact test If the specimen is fixed in a testing machine and the energy is applied by mean to impact a load until its fracture occurs. The graph shows the impact test results of different specimens. Failure analysis. It is done on the basis of 14 step-by-step processes. The first 8 deals with the primary investigation, starting with the data sample collection. In this, the sample of the material is collected, preliminary examination and visual inspection. In this, the visual inspection before cleaning is necessary. Non-destructive test. This test can also aid in assessing the quality of the material. Mechanical testing. It is the hardness test which can be used to evaluate the heat treatment of the material. Specimen preservative is needed because when the fracture is exposed to the air, it gets oxidized. Microscopic examination. This visualization inspection of the fracture is done at a low magnification of 280x. Microexamination. This is done by the scanning electron microscope. Metallographic examination. This deals with the polished or polished as aged specimen. These remaining 6 stages are fracture identification, chemical analysis, fracture mechanism, service testing, conclusion, and recommendation. They are concerned with what happened and why happened. Now from this project, we can conclude that both this characterization and failure mechanisms are the most important things for the product development. Thank you.